So, the topic we will be discussing today is seating arrangement. So, arrangement is basically a plan which specifies how a group of objects or persons are placed, their positions in a particular situation or framework. It represents the pattern which may be linear or circular. For example, the seating arrangement of a class or how we sit in the auditorium. Seating arrangement can be of two types, linear or circular. Linear arrangement can be further divided into horizontal, vertical, and diagonal. Circular arrangement can be of two types, when people are facing inwards and when people are facing outwards. So, linear arrangement is a logical arrangement of objects or person either horizontally, vertically, or diagonally. For example, series connection of resistors and how we sit in the class. If objects or persons are arranged in a circular manner, then the arrangement is known as a circular arrangement. There are two types of circular arrangement, facing inwards towards center. When objects or people in an arrangement are facing towards the center of the circle, then it is known as facing inwards circular arrangement. For example, a round table conference. And the other type is facing outwards away from the center, when every object or person in an arrangement is facing outwards away from the table. For example, when we play musical chairs, we are facing outwards. Now, let's try a question. The question is as follows. 6 students P, Q, R, S, T and U are sitting in 2 rows. 3 are in each row. T is not at end of any row. S is second to the left of U. R is the neighbor of T. Q is the neighbor of U. Arrange the members of 2 rows who is sitting diagonally opposite to Q. So we were already given that there are 2 rows and S is the second to the left of U. So we have that S, leave a seat blank, and then U, and the same with the second row. Now it is also given that T is not at the end of any row. That means that it is not at the starting or the end, and so it means that it is in the middle somewhere. And R is a given neighbor of T. It is also given that Q is a neighbor of U. And also we want that Q is in the diagonal. That means the last. So, picking out all the cases that are applicable, we are left with S, leave a blank space U in the first row and RTQ in the second row, or RTQ in the first row and S, leave a blank space U in the second row. These are the only cases where Q is diagonal and T is not in the end of it. So all these conditions are matched and we get that S is sitting diagonally opposite to Q. Thank you. I hope you understood the topic well.